November 17, 1944. A field northeast of Metz, France. The temperature is 34 degrees Fahrenheit, and it is raining sideways. A German 75mm anti-tank round strikes the front hull of an M4A3 Sherman named Betty Lou at a range of 900 yards. The round gouges a channel through the glassy plate and deflects upward into the gray sky. 11 seconds later, a second round hits the turret cheek and shatters. The crew inside, 5 men, average age 22, hears the impacts as hammer blows against a church bell. Then the gunner finds the muzzle flash in his periscope, the turret swings, and the German gun position ceases to exist. Betty Lou takes 2 more hits that afternoon. That evening, her crew eats dinner, all 5 of them. You have heard the other version of this story. You have heard that the Sherman was a death trap. You have heard the nickname Ronson, light's first time every time. You have heard that American tankers were sent to war in rolling coffins while German engineers built masterpieces. And here is the strange thing the archives tell us. By the end of the war, a crewman inside a Sherman had a better statistical chance of surviving the destruction of his own tank than a crewman in almost any other tank of the Second World War. When the United States Army studied its knocked-out tanks in Europe, it found that on average, when a Sherman was penetrated and destroyed, 4 of the 5 men inside walked away. In the T-34, the number of survivors was often 2. The death trap, it turns out, was the safest place on the battlefield to lose a tank. That did not happen by accident. It happened because between 1942 and 1944, American engineers conducted one of the largest and least celebrated safety programs in military history. The Tiger is famous. The Panther is famous. The 88 is famous. Even the Sherman's flaws are famous. But the 15 specific engineering decisions that quietly transformed the Sherman from a vulnerable early war design into the most survivable crew environment of the war, those have been forgotten. Nobody builds monuments to a fire suppression bottle. Nobody makes movies about the angle of a hatch spring. So today, we are going to open the hull and look at them, one by one. 15 tricks. Some brilliant, some crude, all of them written in the only language that matters, the number of men who came home.
The first trick begins with a chemistry problem, and it begins with a myth we need to kill. Early Shermans burned. That is true. British operational research teams in North Africa and Normandy examined hundreds of knocked-out tanks and found that when a dry stowage Sherman was penetrated, it caught fire between 60 and 80% of the time. But when the researchers crawled inside the burned hulls, they discovered something that contradicted everything the troops believed. The fires were not gasoline fires. The gasoline tanks, sealed in the rear sponsons behind the engine firewall, usually survived penetration intact. What burned was the ammunition. Dozens of 75mm rounds stored in open racks in the sponsons above the tracks, exactly where an incoming shell was most likely to pass. A penetrating round did not need to hit the ammunition. It needed only to spray white-hot fragments across the propellant cases, and the propellant did the rest. The engineers at the Ordnance Department read those reports and produced an answer of beautiful, almost absurd simplicity. They surrounded the ammunition with water. In the wet stowage program, every ammunition rack was rebuilt as a double-walled steel container, and the space between the walls was filled with a mixture of water, ethylene glycol to prevent freezing, and a rust inhibitor. 37 gallons of it distributed around the shells. When a fragment now tore into a rack, the liquid flooded the damage, quenching sparks and soaking propellant before it could ignite. The results were not incremental, they were categorical. Ammunition fires in penetrated wet stowage Shermans dropped from as high as 80% to between 10 and 15%. One design change, one tank of water, and the Ronsons simply stopped lighting. The second trick was where they put that water-jacketed ammunition, because the engineers understood something that sounds obvious and was revolutionary. Geometry is armo. In the redesign, the ammunition left the sponsons entirely, left the flanks of the tank, the widest and most exposed real estate on the vehicle, and moved down to the floor of the hull, beneath the turret basket, below the level of the tracks themselves.
To hit those rounds now, a German gunner had to send a shell through the suspension, through the lower hull, and downward into the floor, a shot that battlefield geometry almost never offers. The Panther, for comparison, carried its 75mm ammunition in unprotected racks lining the sponsons for its entire production run. German engineers knew, they read their own burn reports, but German industry in 1944, hemorrhaging factories under bombardment, could not afford to stop the line and redesign the hull interior. American industry stopped the line, redesigned it, and shipped the result by the thousand. The third trick was cruder, faster, and saved lives while the elegant solution was still in the pipeline. In 1943, before wet stowage reached the factories, Ordnance ordered a stopgap, slabs of 1-inch applique armor plate welded directly onto the hull sides at exactly 3 positions, the 3 positions covering the ammunition racks inside. If you look at photographs of mid-war Shermans, you can see them, rectangular patches riding on the hull like bandages. That is precisely what they were. The crews called them that. German gunners learned to aim at the patches because the patches announced where the ammunition lived, and even so, the extra inch of steel defeated fragments and degraded penetrations often enough to justify every pound. It was an ugly fix. It was also on tanks in the field within months, while a comparable German modification program would have taken a year the Reich did not have. The fourth trick was carved into the front of the Sherman, and it corrected the Sherman's original sin. The early M4 hull front was a 51mm plate sloped at 56 degrees, good numbers on paper, ruined in practice by 2 protruding armored hoods for the driver's and bow gunner's vision, plus a patchwork of welded joints and bolted fittings. Every protrusion was a shot trap, a vertical face standing up out of the slope, and German gunners found them. Battle damage surveys showed penetrations clustering around the driver's hood like moths around a lamp. So in 1943, the engineers threw the front away and started over. The late-war Glacius became a single, uninterrupted plate, 63.5mm thick, set at 47 degrees, with no hoods, no shot traps, and no weak welds crossing the strike zone. The effective horizontal thickness of that plate exceeded 90mm. Betty Lou, the tank in our opening, wore that Glacius. The 75mm round that skipped off her bow in November 1944 would have gone through the 1942 front like paper through a comb. The fifth trick lived in 2 red steel bottles bolted behind the engine bulkhead. Every Sherman carried a fixed fire suppression system. 2 10-pound cylinders of carbon dioxide plumbed through lines into the engine compartment, triggered by pull handles at the driver's station and, critically, by a second set of handles on the outside of the hull, so that a crew that had already bailed out could still fight the fire from the ground. 2 portable extinguishers rode inside the crew compartment as backup. It sounds unremarkable until you go looking for its equivalent in the tanks the Sherman fought. The Panther's answer to engine fires, and the Panther had chronic engine fires, its Maybach HL230 packed so tightly that fuel lines rested against hot components, was a small automatic extinguisher that sprayed when a thermal switch tripped, frequently after the fire was already established. The difference was philosophical. German design assumed the machine would function. American design assumed the machine would be hit, would burn, would fail, and engineered for the minute after failure. The sixth trick was the wall. Between the Sherman's crew compartment and its engine ran a full steel firewall, and the fuel system was engineered so that the tanks, the lines, and the shutoff valves lived entirely on the engine side of it. A fuel fire aft of the bulkhead had to defeat a sealed steel barrier before it could reach the men. Crews could cut fuel flow from inside the fighting compartment and let the fire starve against the wall while they escaped. Read the after-action interviews collected by the armored force, and you find the same sentence in different handwriting over and over. The engine compartment burned, and we got out. That sentence is the firewall talking. The seventh trick is the one no museum label ever mentions, and it may have saved more men than the armor did. Getting out of a burning tank is a foot race measured in single seconds, and the early Sherman made 3 men run that race through one small turret hatch, the commander's,
while the gunner and loader queued behind him in the smoke. The fix came in layers. Hatches were enlarged, hatch springs were fitted, torsion assemblies balanced so that a 100-pound steel lid could be thrown open with one hand by a wounded man lying on his back. And in 1943, the engineers cut an entirely new oval hatch into the turret roof above the loader, giving the most trapped man in the tank his own door. Timed escape trials at Fort Knox produced a number that ought to be more famous than any armor statistic of the war. A full Sherman crew could evacuate the vehicle in under 20 seconds. British trials on the Tiger's heavy, unsprung hatches told a grimmer story, and the loss records agree. A knocked-out Tiger frequently took a third of its crew down with it. The Sherman, on average, took one man, often none.
The eighth trick was cut into the floor. Behind the bow gunner's seat, the Sherman carried a belly escape hatch, a way out that opened downward, into the shadow between the tracks, on the side of the tank the machine guns could not see. A tank crew bailing over the top of a tank under fire is silhouetted against the sky. Infantry veterans on both sides described shooting tank crews off their own decks. The belly hatch let men drop into cover and crawl out under their own hull. Infantry learned to love it for a second reason. A Sherman could straddle a wounded rifleman under fire, and the crew could pull him up through the floor. There are Silver Star citations built on that maneuver. The hatch weighed almost nothing, cost almost nothing, and appears in no comparison chart ever printed about tank warfare, because comparison charts measure how tanks kill, and this was engineering for how men live. The ninth trick did not protect the crew with steel at all. It protected them with time. The Sherman carried a Westinghouse gyro stabilizer on its main gun, a gyroscope-governed hydraulic system that held the barrel steady in elevation while the tank moved. It was temperamental. Crews needed training to trust it, and many switched it off, but the crews who mastered it gained the most valuable second in armored combat, the first one. A Sherman could decelerate out of a move and put an aimed round on target, while a Panther crew, whose gun had no stabilization of any kind, was still settling their sight. And the arithmetic of tank survival in 1944 was brutally simple. In the majority of tank versus tank engagements on record, the vehicle that fired first accurately won, regardless of which one had thicker armor. The 10th trick spun the whole turret, and it is the trick German tankers themselves testified about. The Sherman's turret traverse, hydraulic on most, electric on some, could swing the gun through a full 360 degrees in about 15 seconds, and it did so at full speed, regardless of what the engine was doing. The Panther's hydraulic traverse was driven off the main engine, which meant its speed depended on engine RPM. At idle in ambush, exactly when speed mattered, a full rotation could take more than a minute, and the manual backup wheel was slower still. Post-war interrogations of German tank crews return again and again to the same complaint. In a close fight, in a village, in the bocage, the Sherman's gun always seemed to be pointing at them first. It was not seeming. It was a pump. The 11th trick was glass. The late Sherman was, for its era, extravagantly supplied with vision. Periscopes at every crew station, an azimuth-linked periscope sight for the gunner, and from 1943 onward, an all-round vision cupola for the commander, 6 laminated bullet-resistant glass blocks in a ring, giving him a continuous 360-degree view with his hatch sealed. The German tank commander's traditional advantage had always been fighting head out of the hatch, seeing everything, exposed to everything. The statistics on German commander casualties are their own quiet tragedy. The cupola let a Sherman commander see nearly as much with 60 pounds of steel and glass around his skull. You cannot shoot what you have not seen, and you cannot survive what you never saw coming. The cupola addressed both directions of that sentence at once. The 12th trick was survival through mud. A tank that cannot move is not a tank. It is a target with a serial number. The Sherman's early narrow tracks pressed into soft ground at roughly 14 pounds per square inch, and in the flooded polders of Holland and the winter fields of Lorraine, bogging was death. A stuck tank drew German guns the way blood draws sharks. The engineers answered twice. First, with duckbills, extended end connectors bolted to the outer edge of each track shoe, widening the footprint in the field in an afternoon with a wrench. Then, definitively, with horizontal volute spring suspension and 23-inch wide tracks on the M4A3E8, dropping ground pressure to around 11 pounds per square inch, into the class of the wide-tracked Russian tanks that had humiliated the Wehrmacht in the mud seasons of the East. The Easy 8 crossed fields that winter which would have swallowed a 1942 Sherman whole, and every field crossed instead of skirted was an ambush not walked into.
The 13th trick was silence. The Sherman ran on rubber block tracks, a track technology built on America's overwhelming synthetic rubber capacity, the same industrial base we covered in the Standard Oil story. Rubber-shod tracks on hard ground produced a fraction of the noise of the all-steel tracks that announced a Panther's approach from a kilometer out. Soviet Guards units receiving Lend-Lease M4A2s reported using them specifically for night infiltration marches because the Germans could not hear them coming. Acoustic signature appears on no armor chart, but ask any veteran of an ambush which he would rather have, 20 more millimeters of steel or the enemy not knowing he is there. The 14th trick was in the fuel filler cap, and we have told part of this story before on this channel. The M4A2 Sherman, the twin diesel variant, two Detroit 671 bus engines bolted side by side, burned diesel fuel with a flash point above 125 degrees Fahrenheit against gasoline's flash point of 45 degrees below zero. Diesel does not ignite from a spark, it must be heated and atomized. A penetrating hit that would have flashed gasoline vapor into flame often left a diesel Sherman smoking, ruptured, and unburned, with 5 men climbing out. The United States Army, standardized on gasoline logistics, sent nearly every diesel Sherman to the Marines and to Lend-Lease, and the Marine tankers on Iwo Jima and the Soviet Guards crews on the road to Berlin both recorded the same appreciation in almost the same words. This tank does not want to burn. And the 15th trick is the deepest one because it protected not the crew of one tank, but the crews of all of them. The Sherman was engineered from its first drawing to be repaired. Its engine and transmission were designed as modular units that ordnance companies could swing out with a wrecker crane and replace in hours, in a field, in the rain. Its parts were interchangeable across 11 factories to tolerances German industry never attempted. We have seen what German maintenance officers thought of that in the spare parts story. And behind the fighting line rolled a fleet of M32 armored recovery vehicles, Shermans converted into rescuers of Shermans, dragging knocked-out hulls back to workshops under fire. The consequence hides in a statistic that rewrites the whole death trap legend. In the European campaign, roughly half of all Shermans knocked out in combat were repaired and returned to battle, many of them more than once. A German tank abandoned for a broken final drive was gone forever. There was no fleet of recovery Panthers, no ocean of spare gearboxes. A Sherman was nearly immortal at the fleet level. The tank died, the tank came back, and every resurrected hull was a crew that rode protected steel instead of a truck bed. Now, weigh all 15 against the machine on the other side of the field, and be honest about it, because this channel does not win arguments by pretending. The Panther, hull for hull, was the better duelist. Its long 75 defeated the Sherman's front at ranges where the Sherman 75 could not reply. Its glacis was a masterpiece. In the open, at range, one Panther in a prepared position was worth several Shermans, and American tankers paid the price of that arithmetic in places whose names their families learned from telegrams. But German engineering optimized for the moment of the duel, and American engineering optimized for everything surrounding it. The fire after the hit, the 20 seconds of escape, the mud before the fight, the workshop after it. The Panther's own crews burned above unprotected ammunition racks their factories never found time to fix. Its turret crawled at idle. Its engine compartment caught fire without being shot. Germany built a magnificent answer to the question of how a tank kills a tank. America spent 1943 and 1944 answering a different question, how a 22-year-old survives the worst afternoon of his life, and answered it 15 times. The lineage did not end in 1945.
Open the turret of an M1 Abrams today, and you will find the main gun ammunition sealed behind sliding blast doors, beneath roof panels engineered to blow outward and vent an ammunition fire into the sky instead of into the crew. The direct doctrinal descendant of a rack full of water and glycerin designed in 1943. The Abrams automatic halon fire suppression, its crew compartment isolation, its design requirement that survivability be measured in crew lives rather than vehicle losses. Every one of those requirements cites lessons written in the burn surveys of Normandy. The engineers who read those charred hulls 80 years ago founded a discipline that now protects every American who climbs into armor. And for that matter, every airline passenger who has never wondered why the fuel system is designed around the assumption of failure. Betty Lou's crew came home. So did tens of thousands of others, out of tanks that history remembers as coffins and the data remembers as lifeboats. The Germans built the tank that was hardest to kill. The Americans built the tank that was hardest to die in. And in the only ledger that ever mattered, that was the better machine.